All right. Now, let's say that we have this picture right here, and we want to find the missing angles, okay? Now, notice that we have 1, 2, 3, 4, 5 angles here. So we have a pentagon, and we want to find these two missing angles. But notice, of course, that these two angles have the same marking. Therefore, they are congruent. So if we find one of these angles, we have found the other one. Now, how do we do that? Well, we go back to our trusty formula here. N minus 2 times 180 degrees. And we have to also find out what the entire thing equals to, what the entire sum of the interior angles is, and then that will help us find out what these two angles are. So, let's do the math. First, we're going to find the sum of the interior angles of a pentagon, which is a 5-sided figure. So, take this formula right here, and we're going to do 5 minus 2, because n is the number of sides, times 180 degrees. 5 minus 2 is 3, times 180 degrees, gives us 540 degrees. Again, you can use your calculator to find that. So we know that these 5 angles right here add up to 540 degrees. Now the question is, let's find angles K and L. So to do that, I'm going to remember your 540. And what we're going to do is we're going to take this angle, this angle, this angle, this angle, and this angle, and add them up to get 540 degrees. So I'm going to set up 68 plus 105 plus 109. And since we do not know what these two are, we'll call them both x. So this is plus x, and then remember the number of degrees the pentagon was? That's right, 540 degrees. Okay? So we've set up our problem. Now we just got to combine like terms and solve for x. So we know that if you use your calculator, just taking 68 plus 105 plus 109, well, let's see. That's going to give you 282. Okay? Since these both have an x, we just add those two up to give us plus 2x. We bring down our 540. Okay? And now, again, it's a straight algebra problem. We're just going to solve for x. So, I'm going to take away the 282 from both sides to get x by itself. And I'm going to get 2x equal to 540 minus 282 gives us 258. And then divide 2 to both sides. Cancel those out. I'm going to get x equal to 258 divided by 2, which is 129. So, if I wanted to answer the question, what does angle K and what does angle L equal to, then I would write it as follows. The measure of angle K equals 129 degrees, and the measure of angle L equals 129 degrees. So now we have found all the angles for this pentagon. Now, let's say that we want to talk about exterior angles, because we've already done enough with the interior angles. So let's say we talk about exterior angles. Follow me. We have this shape right here. Again, you will see that I've numbered some angles around, but also notice that I've shown it with the exterior angles, because remember, exterior means outside. I have 1, 2, 3, 4, 5 angles, so therefore we must have a pentagon here for our shape here. Now, this exterior angles theorem is a lot simpler to remember than I believe than the interior angles theorem, because it works the same way for any polygon that you have. To do that, all you have to remember is that the measure of angle 1 plus the measure of angle 2 plus all the way until you get to the last measurement, which we'll call n, because we'll say n is the number of sides, equals 360 degrees. That's all you have to remember. Exterior angles, the sum of the exterior angles adds up to 360 degrees. And the reason is because if I start here and go around and around and around, I've formed a 360 degree angle, a 360 degree circle. Okay? So that is what's happening here. All these angles add up to 360. Now, do you happen to know which angle or which polygon has the same sum of interior angles as sum of the exterior angles? Any guesses? Ah, very good. It's a quadrilateral. A quadrilateral is the only shape, or only polygon, where the sum of the exterior angles and the sum of the interior angles equal the exact same number, which is 360 degrees. All right? So, just want to give you that fact. Now, what we're going to do is we're going to put this this equation or this theorem into motion. Because now what I'm going to do is I'm going to give you five labels or the amount of each angle to find out what a missing angle is. All right? So let me erase this. I'm going to keep that up here just so you can have it. And let's talk about what the angles are. So let's say that angle 1 is 66 degrees. We'll say angle 2 is 77. Angle 3 is 82 degrees. And angle 4 is 62 degrees. But then you say, Mr. Swisher, you've only given me 4 angles. You got to find the 5th one. So all we got to do is take these 4 angles that I've just given you, we're going to add them up, and then we're going to use our exterior angles theorem, the sum of the exterior angles, to come up with the amount of that missing angle. So this is what we're looking for. Measure of angle 5. We don't know what that is. Okay? So here's how we're going to do it. Take 66, 77, 82, 62, and x, because we don't know what this is, and set it equal to 360 degrees. Now all we got to do is add up the 4 numbers here. We got 66, 77, 82, 62. I'll give you a moment to use your calculator. And I will tell you now that the answer, when you add these up, that's 140, that's 143, that's 225, that's 287. So 287, you still have your x, equals to 360. And now we're just going to solve for x. Very simple. Subtract 287 from both sides. Zero that out. I get x equal to 360 minus 287, which is 73. So the missing angle 5 for this theorem is that it's 73 degrees. And again, you can check your work to make sure that it works, but you will see that 73 degrees is the exterior angle on that 5th vertex. Because all those are your different angles. You'll see that this angle matches up with that for 360 degrees.